So discrete mathematical indulo discrete mathematical structures we can learn something here. The third unit, theory of inferences. Theory of inferences for statement calculus. For statement of theory of calculus we can learn here today. So theory of inferences for statement of the calculus we are learn here what is meant by validity of an argument and able to distinguish between validity and soundness of an argument. And establish the validity of an argument using the truth table method is a false or true. You will learn a few laws of inferences of statement logic and new few rules of inferences. To establish the validity of conclusion using the rules of inferences in conjunction with the laws of inference and few logical equivalences. To show that a few given premises are consistent or inconsistent and establish a given conclusion using the method of contradiction. So we are doing the why it is a contradiction we can learn. So what is the inference will be used the designate of a set. It is a premises of a accompanied by suggested of the conclusion we are taking here regardless of whether or not conclusion is a logical consequences of the premises. There are faulty inferences. So faulty inferences we are taking and the valid inferences. Therefore, each inferences can be written on implication as follows, as we can write here. Conjunction of premises. Conjunction of premises to conclusion. We are taking conjunction of premises to conclusion. So theory of inferences provides rules of inferences or principles of reasoning towards inferring a conclusion from a given set of premises. The process of deriving a conclusion from a finite set of premises by using the established laws. It is a reasoning. What is the reasoning is called as formal proof, that is called, or a logical deduction we will take in. So in the mathematics, the theorem is provided by constructing a proof with a sequence of statements that form an argument. The statement used in the proof of includes some axioms, but a few theorems results proved earlier. We know that. But inferences is logical process of making of conclusions from a set of given premises, laws and rules of inferences, which are the means used to draw what is the conclusions from other assertions and tie together the steps of the proof. But these methods of the proof discussed in the unit are used in many applications computer science, that is verifying that the computer programs are correct, establishing that operating systems are secure. This we are using in computers also. Then validity using truth tables. Validity using truth tables. So let n be two statements here. Formula we say that B is logically formed. I am writing here. B is logically follows from A. So B is logically means B stands to A. B is valid. So from A, or B is valid conclusion. B is valid conclusion. I am writing here. B is valid conclusion of the premises that is if I'm writing here A stands to be, it is a tautology we can write here, that is A that is equal, that is a symbol. However, this is distinction with the different values between the implications and inferences. The truth of the implication A stands to B does not guarantee the truth table or either A or B. The truth of the inferences where V, P and P Q, that is implies, that is P implies to Q, that implies Q, does not guarantee. Why? Because that is the truth of Q. So we can say that the set of premises, we can say that set of premises H1, H2, and HM, a conclusion we are writing here, a conclusion C follows here. Logically, we can take there logically, if we take here H1 and H2 and so on, we are taking. So logically means H1, H2, Mn, we can follow the logical H1 and all the values should be club H1 and H2 and subs so on HM, that is equal to C. So the set of premises and the conclusions, it is possible to determine whether the conclusion logically follows from the given premises by constructing the truth table. So this method known as, we can take that this truth table technique is explaining. So that is the conditions are there. What is the conditions? I will explain to you. The first condition, identify all the atomic variables, that is atomic variables, that is P, Q, R, S. I'm taking here. That is atom P, Q, R, S appearing in the premises. What is appearing in the premises? We are writing here H1, H2, and say HM. So therefore also is in the conclusion. These values are also, we can take the conclusion in C. Assign all possible combinations, P, Q, R, S, and evaluate the truth values of the, and evaluate the truth values of the given premises, that is we can write H1, H2, and so on HM, as well as C for the considered combinations. But even though identify the rows in the table which elements are H1, H2, HM, and so on. So therefore HM for the truth table for it is only for T we can take here. So therefore, if for every such row, now truth value of C is also, then we say that the conclusion follows from the what is the premises we are telling here. So suppose we can take the show that one problem we can do here. Show that a conclusion C follows from the given premises, H1, H2. So conclusion means what is the C follows the, so what condition they given here? H1, that is negation of P, H2 PR Q, C is Q only they taken. So there is already told conjunction of the premises to conclusion. I am writing here conjunction of premises to conclusion. Conjunction of premises to conclusion. So the truth table we are taking here, negation of P and PRQ. This is negation of P. This is PRQ. That is stands to, this value is equal to stands to Q is given in the problem. Is stands to Q. So now now we can given the truth table, we have to find here the truth table for this one. We are giving the truth table for how we can write the truth table here. So therefore we can write here truth table here. P Q negation of P, PRQ negation of P and P Q and X. So the set of X is what is true. The negation of P is false. So negation of P means yesterday also I told you negation of P means what is the peak exact reverse value T is equal to F. Then PQ or any PRQ. So we can TF, TT means only we can take T here. The negation of P is false. Why? Because PRQ is T, but negation of P is false. So both false is false. So therefore X is, the output is true. Then we can write true, false. We take in that True false means the negation is P is false again. So again that is false means it's true. Then again it's same false. But there is a true false here. The set of X true or false here. We can write T. Then Ft we can write here false and true. Then we can write false, negation of false is true. Again the false, the true false is true here. Then again the negation of P also true. So therefore all three here we can write here T. Then our false we can take the condition here. False we can take the condition that is true. The false is false. The negation of P is false and false. So therefore true false we can write here true. This is the what is the conjunction of the premises to conclusion we are writing here. So therefore X is equal negation of P and P or Q that is equal to Q, which is tautology. C follows from the given principle. What we are taking here, true or false, we are writing. That is the conditions. What we have with the table, we have written this one. Next, check whether the conclusion. Check whether the conclusion C follows from the set of given premises or not. So the check whether the conclusion C follows. The condition given H1 is P2, P implies Q2R, H2 is P and Q, then C is R, they given that. So we can write the construct the table for same the truth table. P stands to Q stands to R and P and Q stands to R. From the above H1 and H2 and C, we can take it, we can form a table here. We can write here P, Q, R, P and Q, Q to R, P stands to Q stands to R. Then H1, H2, H1, H2 to R we are taking here. Suppose we are taking all this is P, Q, R, I am taking T. P and Q, both are truth values, P and Q are T. Q and R also both T values I am seeing here. This is both are true values. This is also P and Q are both true values. This is called true value. Then P and Q also true. So that is why everything is true. Why? Because we are taking all the values of P, Q are taking T. Then I am taking T, true, false I am taking. True, false I am taking here P and Q. P and Q means both are true. That means true. Q to R. TF means we can write here F. P stands to Q stands to R. P stands to P is T. P is T to T. That is T to F. We can write here this is F. Then H1 and H2. We can write here H1 and H2 also we can take here. What is we can take that the H1 is P Q to R and P stands to Q to R. Q to R H1, P to Q to R H2. So these two values we are taking here both are false. This is false. Then H1 and H2 stands to R. So therefore H1 this is only true. So therefore H1 and H2. So therefore this is a condition to R. This is make as true. Then we are taking here true, false, true. Then P and the P is TF. The TF we are taking here. This is automatically F here. Then FT. Then taking here Q to R. This is writing here T. Then P to Q to R. F stands to T. T2 stands to T. Here we are writing here. Then H1 intersection that is F TT. That is F. That is stands to H1 and H2. We're going that the condition that is true. Then I am taking TFF. TFF. I'm taking here TFF. That is TFF means F. T. TFF means FT. TFT. So I'm writing again. This is TFT. Then FTT. We are writing 9 conditions here. FTT. That is again writing F to TF. F to TF. Then again T to TT. That is again I'm telling T to TT. That is T to T. Then F. Then T. So therefore, any false condition is there. H1 and H2 is false. Any one condition is false. We can write H1 and H2 is false condition. So therefore, FTT over then FTF. FTF I am writing here. FT to FF, TF to F, FT to F, then TF to F, then TFT, then TFT. We can write one false condition is there. So therefore, FFT, that is FFT, that is we can write here FT, then TFT, we can write it from the all the false conditions. The last condition, that is false true. True means Q stands to R, that is FF is true, then it is also true, but all false conditions false. So in a case, H1 and H2, we are thinking that H1 and H2 is thinking that any false condition true and false and true. All the true conditions only true and remaining conditions are false. So that's why from this last column of truth table follows H1 and H2 or its tautology. So therefore C follows from the given premises. What is all are true? See here, this is the last condition. C, that is H1 and H2 stands to R. This is called all true conditions. They are given here. So this is called as tautology. Then determine whether the conclusion C follows logically from the premises H1 comma H2. So therefore H1 P stands to Q, H2 negation of P or Q, that is C negation of P. So P stands to Q, negation of P or Q, C negation of P. So we can follow the truth table here. P stands to Q and negation of P and Q and Q, negation of P and the negation of Q stands to negation of P. So we can write the truth table here. P, Q, H1, H2, H1, H2, H1, H2 stands to negation of P. So the earlier conditions I'm writing again, I'm writing here. True, true, both true. So true, true means H1, H2. H1, H2 means first H1 condition is true, second H2 condition is false. So H1, H2 means true, false to false. Then H1, H2. So H1, H2 means that is a compulsory, it is a tautology true. Then true to F I am taking. True to F means H1 is false and H2 is false. So both are and, but this is also false. False to false true between the condition to negation of P. Negation of P means exact of the H1, H2. So negation of the values is a reverse. It is a minor. It is a T is there. It's false. It should be false. It should be true. Then false true. False true means true. This is also true. So true true means true, but it is also true. Then false false, it is called as true, but H1 is true. Why? Because the negation is a false. So therefore H1 is false, but it is true. So the last row is the taken that it is a tautology conclusion that it is a valid for H1 and H2 to P. We are taking that this table here. Then laws of inference for statement logic. Laws of inference for statement logic. It is possible to determine in a finite number of steps whether the conclusion follows from a given set of premises by constructing the truth table. However, This method becomes tedious when the number of atomic variables present in all the formula representing the premises and the conclusion is large. We shall now establish the following laws of inference, which provide the necessary justification for the steps, the deviation, and they become criteria for determining the validity of the arguments. So what is a modus of points? So the law of detachment, what is the modus of that one? If the statement P is assumed, we can take that true. You can write here P is accepted true. P is accepted true, then Q is true automatically. Symbolically, we can Q that P stands to Q. It is true. That's why this is P to Q. So symbolically, Q is true. We can write that the rule of detachment of modus of this one is a validity inferences because. So therefore, P and P the implies Q is a tautology. Why? Because P to Q, if we can take that P to Q is accepted true, therefore Q is true. So the rule of detachment of the or modus pons is valid inferences because so therefore P and P implies to Q that Q is, we can take that it is a valid inferences. It is taken as tautology. Then today is Thursday. The 10 days from now will be Sunday. So we can take the today is Thursday. That 10 days from now will be, we can write that 10 days from now will be Sunday. We can write that one condition here. So there another one hypothetical syllogism. That is transitive rule. That is transitive rule from the tautology. From the tautology, we have to take in here P stands to Q, then Q stands to R. We can take here P stands to Q and Q stands to R. We can take here. So therefore, P stands to R is called hypothetical syllogism or transitive rules. So this may be written as P stands to Q stands to R. Therefore, these conditions are satisfied in syllogism. That is, we can write here P stands to R also. Another example we have to see. If 1980 was a leap year, then 1984 was a leap year. If 1984 was a leap year, then 1988 was a leap year. So in 1984 was a leap year, then 1988 was a leap year. So see here, 1980 was a leap year. Leap year was 1980, 8 years. Then 1998 was also leap year. 1980, 1988. But 1984 was a leap year. They are asking, the transitive rule can be extended is a large 4 years. 4 years means every 4 years is a leap year. 1990, 1980 was a leap year and 1984 was a leap year and 1984 was a leap year than 1990. So 1980 was a leap year, then 1988 also leap year. The transitive rule can be extended to large number of implications. So we can take that P to Q, Q to R, then R to S, that is P to S. Why? Because 1980 is leap, 84 is 88. So 1988, 80 to 80 also we can finding these values. So we can write this condition to this one. The De Morgan's law. De Morgan's law I'm writing here. Negation of P and Q. Negation of P and Q. Sorry, P. Negation of P and Q. Negation of PR. Negation of Q. So therefore, condition is negation of P and Q. That is negation of P or negation of Q. This is a fundamental of De Morgan's law. Then contrapositive rule. Contrapositive rule. P stands to Q. That is negation. Exact negation Q. That is negation of P. This is all a modulus. Total it can be written as P stands to Q. That is negation of Q. Negation of Q means what we have write? P to Q we can write. Negation of Q means that is immediately we can write negation of P. We can write here P stands to Q and Q is false. Why? Because Q is false. Then P is also false. P is also false. We can write. This is called contrapositive rule we have to write here. One example we will take here. State the contrapositive, the following. If ABC is a right angled triangle with B 90 degrees, then modulus of AB square plus BC square is equal to modulus of AC square. So ABC is a right angled triangle with B 90, AB square plus BC square is equal to AC square. So solution we have to write here. AB square plus BC square not equal to AC square. Why? Why means that the triangle ABC is not a right angle triangle. AB square plus BC square not equal to AC square. Why? Because it is triangle ABC not right angle triangle. So therefore this is we did not triangle, we can that one. Then one definition we can learn here, disjunctive syllogism. We will write the disjunctive PRQ. So negation of P, what we will write is Q. Why? Because P and negation of P, both are exact opposite. So therefore remaining value is called disjunctive of syllogism. All of you understanding? So this is Q. Another one, dilemma. You can learn here dilemma. You can write here P and Q. P to R, then Q to R, P to R, P and PR, Q. So therefore we can write this is that is a dilemma, we can write it. Then law of contradiction. Law of contradiction. Law of contradiction. Let P denote an arbitrary statement. Let P denote an arbitrary statement and F naught a contradiction. So we can verify that. We can verify that negation of P to F naught. Negation of P to F naught stands to P. So negation of P is the reverse value of F naught to P. It is a tautology. So the law tells that the P is a statement. Negation of P to F naught, negation of P to F naught is true, then negation of P must be false. Why? Because negation of P is true, the negation of P exactly remaining, again we will prove that it is a false. So therefore, because F naught is F naught is false, then for F naught is false, therefore P is true. So therefore, there is the law of inferences. Therefore, law of inference is called the law of contradiction. Contradiction may be written as negation of P to F naught to P. This is the condition. The rule of contradiction. The rule of contradiction is the basis of the establishing the validity and argument called the method of proof. The method of proof by contradiction. So therefore, now list of all laws of inferences we can do here. So therefore, first one, law of inference, related logical implication, name of the law. So therefore, PQ, that is earlier written Q. This is related to the logical implication we are writing P, and P stands to Q, that is Q. This is called rule of detachment. This is called name of the law. This is called as a rule of detachment. We can write here. Second condition. P stands to Q, Q stands to R. We learned this is in the leaf year. P stands to R. That is P stands to Q and Q stands to R, stands to P stands to R. This is hypothetical. This is called hypothetical syllogism. Hypothetical syllogism we can write here. Hypothetical syllogism. Then third condition. P stands to Q, that is negation of Q. Negation of Q should cancel here. This is, we can write negation of P. This is also, we can write P stands to Q and negation of Q, that is negation of P. This is modulus of tollens. Modulus of TOLLENS, tollens. This is the third condition. Then we will learn the fourth condition, PQ, that is, we can write P and Q, we can write here. That is no law. This is rule of conjunction. Rule of conjunction. Then 5, P and Q, sorry, PRQ, that is a negation of P. Negation of P means the both should be cancelled. I already told that. I told that P to Q, that is negation of P stands to Q. This is called disjunctive syllogism. Negation of P to P. Negation of P to F naught stands to negation of P to F naught P, rule of contradiction. So negation of P to F naught, that is negation of P to F naught P. You can write here negation of P to F naught P, that is rule of contradiction. The seventh one. P and Q, that is P. P and Q, that is P. This is rule of conjunctive simplification. Rule of conjunctive simplification. P by P and P R Q, that is P stands to P R Q, that is rule of disjunctive. And means conjunctive, R means disjunctive. Rule of disjunctive simplification. P and Q, we can write P stands to, Q stands to R. So we can write P R, Q stands to R, we can write here. So therefore that is P stands to R and Q stands to R. That means P R Q, that may be simplified here. That may be simplified here, P R Q. So this is rule for proof by cases. Rule for proof by cases. Rule of conditional proof, sorry. Rule of conditional proof. P to R, that is Q to R. P and Q to R. P to R and Q to R. That implies P to Q and R. This is so this is rule for proof by case. P to Q, R to S, then P R R, we can take that this is Q R S. That is, we can raise ruler P to R, R to S, P to R, P R R, then Q R S, we can write one. This is rule of dilemma. Rule of dilemma. Another condition, P to Q, then R to S, negation of P or negation of S, we can write this condition, negation of P and the negation of R, that is P to Q and R to S, and negation of Q or negation of S, and negation of P and negation of R. This is, we are writing rule of disjunctive dilemma. Rule of disjunctive dilemma. So this is all the 12 conditions we have proving the list of laws, inferences, what we are doing here, law of reference, related logical implementation, what law we are using here. We can writing these conditions in the earlier. This is the one of the frame. Then validity using the rules, validity using rules of the inferences. So we describe the process of the derivation by which then demonstrate the particular formula is valid a consequence of the given set of premises. For this, we give two rules of inference which are called P and T. Rule A. What rule A? A premises may be introduced at any point the derivation. A premises may be introduced at any point in the derivation. Rule T. A formula S may be introduced in a derivation if S is tautologically implied by any one or more of the preceding formulas in the derivation. So a formula S may be introduced in a derivation is S is tautology implied by any one or more of the preceding formulas in the deviation we are taking here. An example we can take here. Show that the U is a valid conclusion from the premises. So P to R, Q to R and S, and negation of R, negation of T, R, U. That is, we can take P and T. That is, we can take from the above condition, that is U. So we can take the one solution here. First condition, P to Q, that is premise. To Q to R, S, this is also premise. Then third one, P to R and S. And S. From 1 and 2, from premises, first and second conditions are first and second conditions premises 1 and 2 by transitive rule. P and T premise and T premise. P from 4 above P and T means by conjunction. By conjunction we will take here. Then sixth one, R and S from 5 and 3, that means 5 and 3. So 5 and 3 means is a P. From 5 and 3 is a modus ponens. Modus ponens. R, that is a 6 by, from the sixth one R is that is a by conjunction. By conjunction from 6 by, it is conjunction. Eighth one, negation of R, OR, negation of T or U, that is associative law of V. Associative law of V. And then ninth condition, or V, that is a 2U. This is premises. This is called as premises. Then negation of R and the negation of T or U. This is associative law. This is associative law of V. Then negation of R, T, that is U, by De Morgan's law. By De Morgan's law. T. From 4, what is the 4 here? P and T, that is a premises. So by the rule of conjunctive, it is from the rule of that's one, we can take the T's from the 4 of the condition. From the 4 of the condition by rule conjunctive simplification. 12, R and T from 7 and 11 we are taking here the condition 13 u by 10 it is a disjunctive syllogism. So this is what we are taking here. These conditions we are taking here from the conditions. So therefore, we can writing these formulas from the validity using of the rules of inferences.